Right. Then here, trying this. Now, this nitrogen can give an electron to the other nitrogen. This nitrogen may be, how we know that? Here, first, because of this, I can break this bond into this side. We have a 5 bond here. So that 5 bond has 2 electrons. Then 1 electron may be taken by this. Both of those electrons will be taken by this carbon. Then because carbon has an extra electron, it has a negative charge. This has now positive charge. And octet is not completed around this nitrogen. So one of these electrons again will be given to this nitrogen. Because of given an electron, this become negative and this become positive. Now we have positive negative, so it become neutral. So I can remove these positive charges. Then because of the presence of these 2 unpaired electrons, so unpaired electron on each, then it will form a bond like this. So this is another structure. You are asked to draw 2 structures here, those 2. And we can sometimes try with a triple bond between this nitrogen. Then I will straight away draw that. Hydrogen, carbon, carbon, nitrogen, nitrogen, and oxygen. At least there must be a single bond. So first I put a triple bond here. Because of that triple bond, this become positive, this become positive. And we cannot draw bonds around this carbon. Therefore, you can put a lone pair in order to achieve the octet requirement. And on this, you can put a negative charge. So this will be another structure for the given skeleton or given molecule. So I have drawn 3 structures here, but they ask only 2. Next one, based on the Lewis structure given below, state, actually we have to complete the table. This is the given structure. First of all, what we need to do is we have to identify what they are asking is the hybridization and something. So first identify the hybridization around this nitrogen. It has a lone pair and 1 sigma bond. So it is sp. Here, 1 sigma bond here in the triple bond, another sigma bond here and lone pair. That means it is sp2. Here, sp3 because of 4 repulsive groups. This carbon, sp2, oxygen also sp2. This carbon is sp, this nitrogen is sp, this is sp3. Then Vesper pairs around sulfur, this sulfur. Vesper pairs means sigma bond and lone pairs. How many? 1 sigma in this triple bond, another sigma here and 1 lone pair here. That means altogether 3. Around N3, 1, 2, 3, 4. We have 4 repulsive groups. And C5 is this one. Around that only 3. Even counting around this one, we can get, if you already found the hybridization, you can get it easily. How? sp means only 2. sp2 means only 3 Vesper pairs. sp3 means 4. Right? Like that. So around this nitrogen, it is 4. By sp3, here we have 3 bonds and 1 lone pair. So it is 4. Around C5, it is 3. 1, 2, 3. And C7, What is C7? C7 is this one. It has only 2 sigma bonds and no lone pair, that is 2. So it is sp2. Then N8 is this. It has only 2 again. So, and the electron pairs or lone pairs here, we have around S, we have normally they ask around electron pair geometry, no? Not just the number of electron pairs. So electron pair geometry, shape, and the hybridization. That is the general way. Or even in the instructions, I did not put them. So you will see that they may mention that, no? In what in it. Vesper pairs around the atom, the electron pair geometry around the atom, shape around the atom, and hybridization. So it is geometry, electron pair geometry. Electron pair geometry can again easily be found if 3, it is trigonal planar. If you have 3 Vesper pairs, it is trigonal planar. If you have 4, that is tetrahedral. Again, if you have 3, it is trigonal planar. If you have 2, it must be linear. If you have 2, again, linear. Therefore, here trigonal planar. Fine. This is the center atom. There are 3 other electron pairs. So then they will arrange around the central atom so as to minimize their repulsion like this. So it is trigonal planar. Here it is tetrahedral. And here it is trigonal planar. Again, here linear. Here also linear. Then shape around that. How you can get the shape? If there is no lone pairs of that atom, the shape and the electron pair geometry same. If we have lone pairs, then it may be different. So when we consider this sulfur, we have 2 lone pair, two bond pairs and 1 lone pair. 2 bond pairs and 1 lone pair means it is angular. Like this. Sulfur here. Sulfur, triple bonded nitrogen, and single bonded with the other one, and we have this lone pair. Because of the repulsion felt by the nitrogen, this lone pair, this is angular. Then 4 means it is tetrahedral. The electron pair geometry is tetrahedral, but we have 1 lone pair and 3 bond pair, same as that ammonia. That is called trigonal pyramidal. 3 bond pairs and 1 lone pair means trigonal pyramidal. And this one C5, around that C5 we have only 3 bond pairs and no lone pairs. Therefore, the structure and the electron pair geometry same. Then trigonal planar. And to here, the 7. This is carbon 7. It has only 2 bond pairs, no lone pairs, so it is linear. And this one also linear. And hybridization, we have already identified the hybridization, so you can easily write it. This is sp2. Or by using this one, the Vesper pairs, you can find the hybridization. Now, if 4, that is sp3. Here 3, so sp2. Here 2 means sp, and here also 2, therefore sp. And here, identify the atomic or hybrid orbitals involved in the formation of the following sigma bonds in the structure. Yeah, we have already identified the hybridizations of atoms, so you can easily state the um, sigma bonds involved with this. N1, N1 is sp hybridized, so sp orbital will be contributed for formation of sigma bond. So N1 and S2, it is N1 sp, S2 is sp2. No need to write anything else. Some students are writing that this is a sp hybrid orbital and many things. Actually, no need to write down that. Just sp is enough. Here, just sp2 is enough. Or sometimes some students are putting that hybrid orbital like that. You waste your time only. No marks or additional marks for the additional information. They are asking only the identify the atomic or hybrid orbital. Normally, we know that if it is sp, that is hybrid only. No atomic orbitals labeled as sp. Right? So no need to write that. Just sp is enough. Then N3 and H4. N3 is sp3. We can get it from this table. Hydrogen, if hydrogen involves, it is always oneness. If you are specifying unhybrid orbital, then you have to specify its energy level, whether it is from first or second or third. If you write some p orbitals, unhybrid p orbital, then you have to mention 2p, 3p, like that. Then C5 and O6, C5 is okay, that is sp2 according to the table, sp2, but we have to find what O6. What is O6? O6 here, this one, it is sp2. Then C5 and C7. C5, it is sp2, and C7 here. C7 is sp. N8 sp, and here C9, O9, O9 is here, so it is sp3 hybridized. Sometimes you can put as 2p. Why? If a terminal atom is considered, then no need to consider the hybridization, because hybridization concept is introduced only to find the shape around the atoms. But we know that the terminal atom, they don't have any structure. And if you get that water, the shape around oxygen is angular, but shape around hydrogen, we cannot specify, because at least we have to consider two bonds to give a shape. But here it forms only one bond or bond with another one atom. So there is no shape. Therefore, you can specify that as without its hybridization. No need to consider hybridization. Hybridization considered only to get the shape. Then sketch the above Lewis structure. State in the bond angles as required. Then even in this case, you can use the same name. Then land up 2p or 2p, not both. SPO 2p. Why? It is terminal. This is a terminal atom. This is also terminal atom. So we don't consider that. Even this one, this oxygen also a terminal atom. We don't consider shape around that. Then it may be 2p. If you need, you can put it as 2p. That means this all O6. Even at O6, you can put just 2p. If you just write this 2p only, like this in the exam, you will get marks. Then sketch the above list structure, state in the bond angles as required. Yeah, this is the, I will get that structure. Right. I can use this skeleton. Here nitrogen, sulfur, it's linear, but I start from this because this reason, see, nitrogen, it has bonds like this, carbon behind. I will draw it little above here. Yeah. Sulfur and nitrogen, it is linear like this. Then we have hydrogen here and lone pair here. Because of this lone pair, this is trigonal planar in shape. So I draw this carbon. And again, we have double bonded oxygen here. I will put it here. And then you can get this structure. Carbon, triple bonded nitrogen, and oxygen like this. So this may be the structure. Then here no charges, and you have to mention all the electron pairs. No more electron pairs. Right now you have to mention the bond angle. Normally we compare the bond angles with the known thing. Right? Here the bond angle, normally you can consider the bond angle. If you get the bond angle of this ammonia, that is the well-known bond angle. Right? You can put, here we have this lone pair because of the crowdness, electron crowdness here. Sometimes this may be little bigger than ammonia. In the case of ammonia, it is 107. Right? But here you can use the same angle. 107 or near value. So it's better to put 105 or 6 here. These two angles may be 105 and 105. Uda, in early exams, there was a chance to put the bond angle less than 107 or greater than 107 like that. But nowadays, you are not allowed to do that. You have to specify with a number. That may be correct or wrong or near value. They will give a range. They say 107 plus or minus 2, except for as the bond angle of this. So 105 may be possible like that. So you have to give a number. Here this is 180. In this case, this is 120 normally. If because of the high electron dense region here, this bond angle may be smaller than 120, so you can put 180. Here it is again 180 linear. Here also 180 because it is linear. So very easy. You have to specify only these two bonds. 105, 105, 180, 180 and 80. So this is the accepted values and the correct structure. You have to get the three-dimensional structure like this. For the exact 3D in 2D space, you have to draw it so that you can easily identify the bonds. Okay, that's all about the first question. Then we will go to the second. Normally, the second question is inorganic question. Here, it says that A, B, C, D, and E are five consecutive elements. Consecutive means nearby. In the periodic table with atomic number less than 21. 21 is scandium, less than 21 means from hydrogen to calcium. D has the smallest atomic radius. The variation of the first ionization energies A, B, and E like this. The element A exists in solid state at room temperature. Now you can try like this. The first ionization energy is given, and also it says that D is the smallest. Among the element in a given period, the smallest is group number 18, O noble gas. I will just first write the ionization energy graph for this. First group, second group, third group, fourth, fifth, sixth, seventh, eighth, like this. And again, it is increasing. I just consider the well. Then we have to find something like this. Elements are A, B, C, D, E now. But the ionization energy of A is the highest or the biggest. And D has the smallest size. A is the highest and D has the smallest size. So D may be this. Ionization highest means maybe this. D is the smallest atom. Smallest atomic radius means smallest. That is the smallest. Then you can get like this. We have to consider only 5, right? 1, 2, 3, 4, 5. E, B, A. E must have the least. E must have the least ionization energy. Sometimes it may be here and here. E. I just try it, right? D must be smallest size. D may be possible. D may be such a place. Ionization energy variation of EB A given, but not the D, but D may be this, because if you get from lithium to neon, neon is the smallest. If you get the sodium, argon is the smallest. There are 2 possible places for D. Another 2 here. And another one. Element A exists in solid state. If I try in this way, if I get D as this, then this is the C, B, and A. Then A, B, C, D, E. Another possible thing is A, B, C, D, and E. A is a solid at room temperature. A this. If you get this with A, lithium, beryllium, boron, carbon, nitrogen. This is nitrogen. If you get in this way, this is nitrogen. Nitrogen is a gas. N2 is a gas at room temperature. But if you get A, B, C, D, E like this, then A is phosphorus. Phosphorus is a solid at room temperature. Therefore, you have to consider these elements. A is phosphorus, E is then potassium. That's how you identify or pick those elements. Now D is the smallest, that is argon. Then A is a solid, so phosphorus cannot be this. So, and A has the highest ionization energy among E, B, and A. See, E, B, A. See, that's correct. No? Then the elements A, B, C, D are like this. A, phosphorus, B, sulfur, C, chlorine, D, argon, and E, potassium. Next, of the above elements, identify the strongest oxidizing agent, the strongest reducing agent. Strongest oxidizing agent means oxidizing agent always reduces itself. So which like to be reduced, that may be the chlorine. Chlorine is the one which is to reduce. So the strongest oxidizing agent is chlorine. The strongest reducing agent is the potassium. By potassium is to, and Cl plus electron will go to Cl minus. Potassium will oxidize, giving like this. Yes. The next one. Yes. Then write the molecular formula of two compounds formed by reacting A and C. That is PCl. So write the molecular formula of two compounds. One is PCl3, the other one is PCl5. Phosphorus can form two chlorides like this, but nitrogen cannot. Nitrogen forms only NCl3. Nitrogen cannot form NCl5 because that nitrogen has no empty low line energy levels. Nitrogen has no 2Ds. Therefore, nitrogen cannot form NCl5. So that is another point to identify this A as phosphorus. Next one, write the balanced chemical equations for the reaction of the above compounds with water. Yes, we can write down like this. PCl3 react with water, giving H3PO3 plus HCl. Then 3 water. PCl5 plus water with limited amount of water or 1:1 ratio, then you will get the product POCl3 plus HCl. If you add excess of water, then you will get H3PO4 plus HCl 5 times and 3 water here. If you write these two only one reaction for this PCl5 is enough. Next one, 5 test tubes contain FeSO4, Na2CO3, Cr2SO4 thrice, NH4Cl and AlBr3. That means iron 2 sulfate, sodium carbonate, chromium sulfate, ammonium chloride, and aluminium bromide. These were labeled as PQRS and T. The following tests were performed with the above compounds. What are the tests? First one, when dilute sodium hydroxide was added to the compound P, a clear solution was formed in the presence of a dilute sulfuric. P forms a clear solution evolving a gas bubbles, which react with sodium hydroxide without giving clear solution. That means no precipitates are formed. And P forms a clear solution evolving a gas. a compound which can evolve gas with an acid. See here, the carbonate is the only thing which can evolve a gas with dilute sulfuric. Right? So that may be sodium carbonate. Then P is sodium carbonate. Because of these observations, P is sodium carbonate. Why? Sorry. The sodium carbonate with sodium hydroxide, AQ, because of water presence, it will dissolve, giving a clear solution. And sodium carbonate plus H2SO4 will give us sodium sulfate, Na2SO4 plus CO2 plus water. Right? So this is the gas evolved. Therefore, this P is sodium carbonate. Next one, Q forms a green precipitate with sodium hydroxide, and it is soluble in excess of sodium hydroxide. When H2O2 is added, this turns yellow. Remember that, Putha, if you don't know anything, if you can remember this only. Mokadda? In as basic medium, green turns to yellow means chromium 3+. Actually, there are two things which can give us green color precipitate with sodium hydroxide. One is iron 2+. We have Fe2+, Fe2++ NaOH will give us FeOH twice. That's a green color precipitate. The other thing is Cr3+ plus NaOH will give us CrOH thrice. It's also a green color precipitate, but excess of sodium hydroxide will not change this iron to hydroxide. But if you add excess of sodium hydroxide into chromium hydroxide, it forms CrOH 6,3 minus aqueous green color solution. This is AQ, green. So it says, from a green precipitate with dilute sodium hydroxide solution, excess of sodium and soluble in excess of sodium hydroxide, then it is chromium. So Q is chromium sulfate. According to the given, chromium is available as chromium sulfate. So Cr2SO4 thrice. So Q is chromium sulfate, Cr2SO4 thrice. Write the balanced chemical equations for the observations above. One is here mainly focus on the precipitate and dissolution of precipitate. Therefore, no need to consider the entire chromium sulfate. If you just use this chromium 3+ and sodium hydroxide, that's enough. So you will get full marks for that. Or just OH minus is enough from this. Okay. If you write down OH minus, 3OH minus and CrOH thrice, then it's okay. This is green. The secondly, CrOH thrice plus 3OH minus will give us CrOH 6 times AQ. This is also green in color. And finally, when H2O2 is added to this solution, when the solution, the yellow colored solution is formed. Yes. It will oxidize to Cr6 like this. CrOH 6 times 3 minus plus OH minus plus H2O2 will give us CrO42 minus plus water. Right? Then you can balance it. Here the oxidation number is +3. Here the oxidation number is +6. In this case, the oxidation number of oxygen is -1 into 2 because we have 2 oxygen. Oxygen in this, so this may be -2, then both of these will be reduced to -2. Therefore, the electron difference is 2 electron. Here the electron difference is 3 electron. So you can interchange and multiply here. So this by 2, this by 3. Then the easier, here you can put 2 here. Right. So now this is the classic method of balancing this. Now you need to check how we can balance it. Because this may be little hard to balance. The reason is here you have 3 minus into 2, 6 minus, but here you have just the minuses here, right? So balancing in this way may be little hard. Therefore, what we can do here, see here -4, here -6 and something. So how you can balance this? And you have some excess of OH minus here. If you use in this way, because the minus charge has to be balanced on both sides, right? Minus charges has to be balanced on both sides. So what you can do here, you have to put the only thing you can give minus charges to this solution is OH minus. So you can put some OH minus here, then it will cancel. Right? So here you have 6 minuses, the right hand side must be 6 minus. So you can put 2 OH minus and remove this OH from this. Then check whether it is correct. So here you have how many hydrogen? 2 into 6, 12 hydrogen means you can put 6 water here, but here also you have some hydrogen. Without a method 2 into 6, here 3. Altogether 18. Altogether 18. No? Here 12 plus 6, 18 hydrogen means, but here you have 2, so 8 water. This is balanced and correct and accepted. And another equation you can write down. We don't know which solution they are talking about. Normally, we can say that it may be the initial solution they have given, that is Cr3 plus. Then Q forms a green precipitate with dilute NaOH. It is soluble in excess. And when H2O2 is added to this solution, so if you assume that the solution they are talking about Q, then again you can write it in this way, Cr3 plus available in that. Then the medium is basic because they say the medium is basic. We are adding sodium hydroxide. Then we add in H2O2 without me considering that basic medium.